Okay guys, today we're talking about recursive functions, recursive rules, okay? I actually have the book open to the glossary at the back because I wanted you to actually see what the definition of a recursive rule for an exponential function was. And in fact, there is a definition for the recursive rule for an exponential function, okay? It's a rule that gives the initial value of the function, f of 0, and a recursive equation that tells how a value, f of n, is related to a preceding value, f of n minus 1. Okay? So before we go on, I want to make sure you understand what all this says, because I'm afraid that some of you just heard me say blah, 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 function, blah, 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 function. Right? So let's make sure we understand what's going on here. Okay? A rule, you know what that means, right? You guys are used to rules. Okay? A rule that gives the initial value, what does that mean? Yeah, like the starting value, right? The starting value of a function where f of 0, remember how we talked about when we had the y equals a times b to the x power? What was the a value again? The a value is when x equals 0 in our table, right? So this usually says f of x. So now that it says f of 0, we know that we're talking about that same place, right, when x equals 0. So our starting value when f of 0 when x equals 0. So hopefully you realize that that initial value is going to represent what letter in our regular exponential function? Yeah, a, right? Okay. And recursive equation that tells how a value f of n is related to a preceding value. Well, if I just say f of n, that's just any value, right? N can be any number that I want. Well, then what would f of n minus 1 be? Well, if I'm talking about f of 7, what's this one going to be? What's 7 minus 1?
Oh, it's at 6.
Oh, f of 6. Well, what if this is f of 10? What's this one going to be? F of 9. So it's the one right before it, the preceding value. Does that make sense? Okay. So what has to happen today is we have to be able to take a regular exponential function like we've been used to working with. So like y equals 8.32 times 1.44 raised to the t power. Why did I use t and not x? Yeah, because, right? There's no other reason than because. This particular example I'm doing for you, it had a t in it. Maybe, what would the t probably stand for? Time. Yeah, time. Maybe this is a word problem and t stands for time. It could be an x very easily though, right? Okay? So I need to take this regular plain old exponential function and I need to change it into a recursive model. Okay, a recursive rule. Does that make sense? So what I'm going to do that is I'm going to remind myself what everything actually is in this formula. Right? Normally this is y equals a times b to the x. Right? Remember that? Well, it tells us that f of 0, what was that? What did it tell us that f of 0 was? When x equals 0, or t in this case, what happens when t equals 0? What's this value right here? A 1. Well, what's 1 times 8.32? 8.32. So what if we were talking about right up here in this general model? If x is 0, this is 1. 1 times a is a. So guess what f of 0 equals? A. And then you need to know this. F of n is going to equal b times f of n minus 1. This is the general functions that we're going to use today in our homework. Okay? So if we're doing this particular example right here, what is f of 0? .32, perfect. What about f of n? What do we know for sure over here? We know the b, don't we? What is the b? 1.44 times f of n minus 1. And then I'm done. That's it. This right here is the recursive rule for that exponential function. Hard or easy? Yeah. Some of you are looking at me like, seriously, Miss Kingston, it can't be that easy. Nothing in this class is that easy. Except it is. I would try to give you a harder one, quote unquote, harder, except all I could do was make these numbers bigger. That's the only way I can make this harder. And that's not really harder, is it? The numbers are just bigger. F of 0 equals A. F of n equals B times f of n minus 1. I do want you to see what this helps us do. Okay? This is not required. It's not asked for in the homework. What it's asked for in the homework is right here. You're given this exponential function and you're asked for the recursive function. I want to make sure you understand how this helps us. Okay? Let's start making a list. What is f of 0? 8.32. What about f of 1? Well, f of 1, I'd have to use this function, right? So f of 1 is 1.44 times f of 1 minus 1. Does anybody know what 1 minus 1 is? Oh, 0. Excellent. This is f of 0.
Teachers, pardon the interruption. The insurance people are now in computer lab 1.
Do we know f of 0? Oh, yeah. We just figured that out, right? That's 8.33. So what's 1.44 times 8.32? I meant 2, not 3. What is that? Out loud. 11 point what? 98. Did you round it? Okay, that's fine. Okay. So f of 1 is 11.98. What about f of 2? We'd start right here again, right? 1.44 times f of 2 minus 1. Well, what is 2 minus 1? Excellent, 1. Wait, do we know f of 1? Oh, yeah, we just found it. 11.98. So what is 1.44 times 11.98? 17.25, is that rounded? Okay, thank you. One more. F of 3. Well, I use this function again, right? 1.44 times f of 3 minus 1. Anybody know what 3 minus 1 is? Oh, 2. Excellent. Wait, do we know f of 2? Yeah, we just found it, right? So what's 1.44 times 17.25? Say it one more time. 24 point. Thank you. So it helps us find values in a function, right? If we know the previous value. Let me see your calculator real quick. I want to show you something, but I got to clear her calculator out real quick. I'm going to go here and put in our original function, that original one, 8.32 times 1.44 raised to the x power, or in the t power, but you know we have to put x in the calculator. Okay? If I go look at the table, look what happens. When x is 1, what is y? 11.98. When x is 2, what is y? Oh my goodness. It's just a different way to look at a function, exponential particularly. Okay? I know your eyes are all big and you're like, this is amazing! Of course it is. Of course it is. Okay? It's two different ways to go around to getting the same information. One is a function, just a regular function like we're used to working with, exponential function, and one is a recursive rule. Okay? Could you see the positives, the pros and cons for each one of them? Yeah? Okay? Any questions?